record on this computer. Beautiful. Now, what we're going to be doing today is a challenge that was given during a competition at one of the best high schools in the country in New Hampshire called Exeter. And I love the competition questions that come out of Exeter, and they're a lot of fun. So what I did is I created a lesson based on the competition questions. So I want everybody to look at page 1, and let's go over the rules. The rules are that we're supposed to find the smallest number of triangles, not the largest, the smallest number of triangles that I can hit every point in a square array, like a 1 by 1 or 2 by 2 or 3 by 3 or 4 by 4. These triangles must hit every single point. Now, there's a couple of more rules that you have to follow, and those are as follows. Each triangle must intersect with at least 3 points. So you can't have a triangle like this. Let me show you. We're going to be using isosceles right triangles. Do you guys see how I am touching point A1? That is not allowed because your triangle has to hit at least 3 points. That's number 1. Number 2, you cannot have overlapping triangles. So do you see how these 2 triangles overlap?
This is gonna be so fun.
Number 3, your triangles can't touch each other. So they have to be separated. They have to be separated. They can't be on top of each other. Now,
Mr. Kramer?
the last thing I want to say to you is that I want you to look for patterns. Somebody said, Mr. Kramer, how can I help?
Can we like use the same dot another triangle use? Or you can't? I mean, like, if you do 2 isosceles right triangles on the AB1, if you do those 2, can you do like two of those? Or wait, first they can't overlap, but can they touch each other's dots?
Nope, they may not. You may not touch each other's dots. So can anybody tell me the solution for a 1 by 1? What is the minimum number of triangles that we can use to touch that 1 dot? Based on the rules that I gave you, Hayden, can you speak up?
0.
Does everybody agree with her?
Yeah.
There is, guys, what we say is we put a 0, everybody put a 0 with a line through it. That's called no solution. There are no solutions for a 1 by 1 array. Now, the next thing we're going to do is you guys are going to go down a little bit and look at the 2 by 2 array. Now I've labeled the points A1, A2, B1, and B2. So you can describe for me what you did. Now I want you to create as few triangles as you can and connect all 4 dots. And you have to be very creative here.
All 4 dots?
You have to touch all 4 dots. It could be 1 triangle, it could be 2, it could be 3. But remember, It has to follow the rules. Okay, we have a solution. Jack?
1.
Well, you have to tell me how to draw it. Tell me where to start.
You start at A2, then you go down to B2.
To B2.
Mm-hmm.
And I'm gonna have to probably spin that around.
Yeah. Then add it all up to B1.
Yeah, but Jack, how can I get a triangle to touch B1 and not touch the other triangles and not overlap? How am I going to do that? So this was a great start. It takes a lot of courage to be the first one, but this is not a solution. Great try. Sarah?
I have a question about them. Like, could they be? Well, I think I might have a solution, but I don't know if it's a rule. Like, we can't do it. So, I did A1, and then I went down to B1. But what I did is I turned it because, like, when you draw it, it's a little easier. And what you can do is make the like you can kind of turn it to an angle, and then it helps, like, where you put the B2, I put on the A1 and flipped it.
Like this?
Yeah, but I just kept flipping it till the straight line was flat against A1 and B2. Was like a straight line like that.
Yeah, but how can you hit all 4 points? That's my question.
Oh, does it have to be one triangle?
No, it can be 2, but as we saw from Jack's, listen, as we saw from Jack's attempt, he hit 3 points with the one triangle, but he couldn't do anything with that single dot, just like we couldn't do anything with the single dot in the 1x1. But I will tell you guys, there is a solution. Kelsey, can you enlighten us?
Maybe if you go A1 to B1 and make the point facing out.
A1.
Can you make it facing out of the square?
Oh, didn't I say you had to be creative? Absolutely. Where do you want to start, Kelsey?
A1 and B1 and make it point out between the 2.
So if you start out above 1 unit above A1, everybody watch. Do you see what we just did? We created one isosceles right triangle that touched all 4 points. Alexander?
For a second, what I was going to say is that, like, the A2, one part of the triangle wasn't touching A2 for a second, and I was about to say, wait a second, it's not actually touching all dots.
Right. So I had to move it slightly. So guys,
Yeah.
The solution for a 2x2 array is one triangle. So put the number 1 under the column, minimum number of triangles touching all dots. And since we had to go outside of the 2x2 array, write the word outside in the next. And we're going to keep a chart of the solutions and see if we could come up with a pattern, because patterns are everything. In fact, patterns are life. There is nothing better than finding wonderful patterns. Okay, everybody now go please to page 2. And on page 2, I've given you 4 different 3x3 arrays. And I'm going to give you a hint that there are two solutions. Your job is to find both solutions. By the way, one is on the inside and one is on the outside. William Z, have you found both?
No,
I
but
know.
I think I know the pattern.
Oh, well, you know what? Before you say what you think you know, why don't you solve the second one? Because you can't find a pattern with one solution. You need at least two, if not three. So Jack has a solution, Jesse and William M and Penny. So why don't I start with Penny?
If and you draw a line from A1 to C1 and then C1 to C3 and then connect the two. And
That is
then
perfection.
using the other three dots, you make a triangle.
Can we say A2 to A3 to B3 and back?
Yeah.
Okay.
No, you have to do A2 to B3 to A3.
What do you guys think? Did we solve it?
Yeah, I was gonna
Yeah.
say that.
Now-
It's the exact
now-
same.
Now, guys, I bet a lot of you got that solution. So we know that the answer to 3 by 3 is 2 minimum. But did anybody go outside of the box? Did anybody do the outside? I'm going to go with Kelsey first.
I was actually able to find 4 different triangles if you go outside.
Oh, okay. Tell me what to do.
So first, if you go A1 to A2 and make a point up.
Yeah, but
Yeah.
does that touch 3 points?
No.
So you're not allowed to do it if it touches.
Oh, then I have a
one
different
or
one.
Okay,
Oh,
but
I have a
remember,
different
you
one.
okay? Go for it, please.
And then to B1.
Say again, please.
A1 to A2 and then to B1.
Okay, I'll have to spin it. Now, remember, guys, if we just change the position, that's not considered a different solution. But I'm really curious as to how you are going to connect all of these.
I think I found it.
Yeah, and I'm going to call on Tess in just a second. Kelsey, finish up, kiddo.
I think you actually have to turn it instead of it being B2, B1.
Okay, like this.
Yeah.
Okay,
And then I went from C2 to C3
got it.
and up to B3.
And then,
Oh, I went to B3.
and then,
Went down.
down where?
So when I went to C3 and went up, I only went up to B3, not A3.
Oh, I'm so sorry. So, got it.
And then go down to C2.
The problem is you'll never get a triangle on
Oh.
A2 and A3 or on 1C. Now, Tess, give it a shot.
I did one big triangle from C all the way to the 1.
You mean C1? You got to give me 2 coordinates for each point.
C1 and
To where?
so I did C1, and then I did
But you have to say C1, 2. I need a second point real fast.
C1 to A3.
A3, got it. Let's see. And then to where? Triangles have 3 points. Go, go, go.
And then to
Okay, I'm gonna test. I'm going to, oh, test. If you did what I just drew, and then you took another triangle, that is the same solution as we got above. It's just in a different position. Sunyi,
So I did C1, then B.
wait, so these are the same. Okay, go ahead,
but
Sunyi.
it's different.
Go ahead, buddy.
C1 and then B1. And B1 connects to B2. And B2
right.
connects to C1.
All right, I'll see if I can accomplish that. Let's see. Like this,
No,
like this.
yeah.
Okay,
And then C2 to B3 to C3 and connect all of those lines.
so C2 to B3 to C3.
Yeah, and then on the top, it's like this giant thing.
Yeah, but unfortunately, that, well, actually, you do follow the rules, but those 3 points can't be in one line. So I like this, Sunyi, a lot. I like your creativity, but those points have to be actually, you know, at different points. They can't be in a line. So
Mr. Crane, I have one.
yes, go ahead, Hayden.
So
I
you
want
do
to.
2 units above A1.
Ah, how many units above?
I think it's 2 units above.
Guess what? Everybody do it. 2 units above. Go ahead.
That's what I was trying to do. And then you like connect to connect to a little further out than C3. And that and then you go back, and I think that works.
You mean A2 to B2 to B3?
No, not that triangle. You did that one.
I'm not sure. What are you saying then?
Actually, no, sorry, that triangle, yeah.
Yeah, that's a great job. So guys, that, and William Z got that too. Did anybody else get that one?
Wait, I have another one.
Everybody draw it. Now
I
remember,
thought you couldn't do that.
now Bayram, the one that you give me now, make sure it's not just one of these two rotated.
Definitely not. Definitely not.
Okay, and if you notice, wait a minute, William had a really, Sunyi had a really cool one, but it had 3 triangles. Ours, both of these solutions have 2 triangles. Go ahead, Bayram.
Oh, so I need 2 triangles only?
Yeah, because we're supposed to find the smallest number of right isosceles triangles.
Oh, I found one with 4, but it's still really cool.
Yes, we will have time to do that at the end if possible. Now, everybody go to their chart on page 1. We had 2 triangles for the 3x3 array. One was inside and one was outside. Now we're going to do the 4x4. Go to page 3, everybody. And this one should go faster. I want everybody on page 3, and I want everybody to now find the only solution. There is only one solution for a 4x4. And I'm not going to tell you, I'm not going to tell you if it's outside or inside, and I'm also not going to tell you how many triangles. So I want you guys to really push yourself.
I thought we were on 5x5.
So Kelsey, did you find it already? And
I think
Sarah?
I did.
Awesome, awesome. Sarah found it. And
I just
try to
have a
try
quick
to
question.
see- Oh yeah, go ahead, honey.
So since now we're doing a 4x4, are there allowed to be 4 in a row? Like
There are
4?
allowed to be 4 in a row, but the other points in the triangle have to be not on that line, because you need more.
It's-
You need 3 non-linear points to create a triangle. But your job is to have the fewest. Now Jack's got it, which is cool. Now here's what I want you guys to do. Prove me wrong if you can. Maybe there is a second solution. I couldn't find one. I could not do it. I tried really hard, but I could not find a second solution. And let's see, who has not shared yet? Alexander, have you been able to find it yet?
No.
Not yet. Jonah, what about you? And Olivia? And Mark?
I think I found it, but I may be wrong.
Okay, good. I know Jack has already shared one of his. Tess, Mark, what about you? I can't really see you.
I didn't find it.
Not yet. Yes. Who said Mr. Kramer?
I have a question.
Yes, go for it.
Can there be 3 triangles or does it have to be 2?
If 2 is not enough, it has to be 3. If 3 is not enough, it has to be 4. Okay? So let's go with Sarah on this one.
Okay, so I think what it is A1 and a unit up to A2, like 2, yeah, just like you did. And then a triangle in B2 to C2 to C3.
I like it.
And then a triangle from A3 to A4 to B4.
Everybody raise their hand if they got the same solution. Awesome,
Mr.
awesome
I
job.
found another one.
I got a different one.
Oh, wait, who just said that?
I found
The word I doesn't help me.
Jack.
Jack,
Kramer?
go for it.
William and Sui.
It's this.
Oh, now Jack, look at C2. Tell me about C2. Does C2 have any triangles on it?
C2.
Yes.
Yeah.
Where? Well, show it to me again then. Because the one you showed me, there is no triangle touching C2. There is no triangle touching point C2. So try again, my friend.
Yeah.
William Z.
This one is.
No, but that's not C2.
I have one.
That's touching C4 and
Mr.
even
Kramer, I have one.
C3 and even C1. William Z.
Oh, mine.
All I see is your loose leaf binder. You have to think about where the camera is when you show it to me. And where is it? Is it up or right? Is it near your left hand? Where is it, buddy? Yeah. You know, William, it would be much better if you could just use your words and describe it for me, because I can't see it.
Okay, then
Come on, start with a coordinate. Go.
line
Up, down, up, down.
A3
A3 to where?
from A to 3.
Well, A3
From
is a
A1 to
point.
3.
Ah, okay.
And then from A1 from
Quiet. It doesn't
from
look
A1 to
overlapping.
C1. From A1 to C1.
Oh, to C1, okay.
And from C1
To
and
A3.
yeah.
And then, and so how would you go to the next one? Come here, at least in front of me. So I
and
can-
then you draw a bigger tri- Can I annotate?
No, not right now, but I want to show you something, William. William, if you tried to make another triangle, you would, again, just like Jack's attempt, it had
No, that's
one.
not how I did it. That's
Yeah,
not
but
how I.
all you have to do, buddy, is give
That's
me the
not-
coordinates. All you have to do is say
Well,
A1
make
to A3 to C1. Give me the 3 coordinates that make the triangle.
Make a bigger triangle than from C3
Nothing.
from
Not
C.
anything.
Can I annotate?
No, I'm gonna move to Sunyi right now. If you want to send me a chat, maybe describing it with the coordinates, you can do that, William. That's the way we're doing this, by coordinates. Go ahead, Sunyi.
Can you make triangles like this?
Yes, you can. But as you can see, how many triangles have you created, Sunyi?
4.
And how many were created in this picture?
3.
Exactly. So our job is not to do the most triangles. It's to do the fewest triangles. So everybody now record that 4x4 took 3 triangles and we had to go outside the box. So everybody do that right now. Go to page 1, 3 triangles, and it was outside. Now, the next one, and William, I'm looking at yours, William, and William, I can't, back it up a little bit, buddy. Back it up a tiny bit. Ooh, I like what you did. I like what you did. Let me see if I can draw it. William did a great job. And I think, and was this the 4x4? I think William did this. And then I think he went outside. Everybody look at this. And then, there it is. Now, what I'm curious about is that different than the one that I came up with, or I'm sorry, the one that, who came up with that one? Sarah, I think?
Yeah.
You know, I have to say, William, this is perfectly fine. This is a great solution. And again, there are only 3 triangles. Now, everybody right now, go to page 4. This one was the actual competition. So this was the question on the high school competition. They gave you a 5 by 5 and they asked you what was the fewest number of triangles. I'm not going to give you any hints at all. But I am going to say to you that there are 2 different solutions, at least. Suni, don't raise your hand until you have at least 2 different solutions. And this is the one where you have to start thinking like a high schooler. And by the way, Suni, how many triangles were in your solution? Can you use your words, Suni?
3.
Very good. Use of words.
Mr. Ray.
Excellent. Yes?
I have one solution.
With how many triangles?
I have 3.
3. Fantastic. Why don't you actually, I want to hear from Mark because I haven't heard from Mark yet. I thought I saw his hand go up. Go ahead, Mark.
So you go A1 1 unit up.
I'm waiting for the next coordinate, my friend.
You go to A1 and 1 unit up and go all the way down to E1.
Keep going.
And then you make from A3 to C5 to A5 back to A3.
So from A3, I get it. From A3 and hold on. I'm gonna have to spin it around for you, buddy. There we go.
Yeah, and then you make a triangle from B2 to D4 to D2 and back to B2.
How many of you got that same solution? Awesome, Hayden, Maeve, awesome job. I've got a bunch of hands that are up, not like blue hands, but like reaction hands. If you could put those down, but I don't know if you're raising your hand. If you want to raise your hand, do it with the blue or actually raise your hand. And Maeve, you had a question?
No, I didn't have a question. I had a different way to do it.
Whoa, let's see it, girl. I am so excited.
Okay, so you go to A1 to D1.
A1 to D1.
Mm-hmm. And then to A to 4.
No, you have to say a letter and a number for each point.
My triangle's the other way around.
Okay, so when you went from A1 to D1, where did it go? Where was the third point of the triangle? The third vertex? So Maeve, you said A1 to D1, which I did.
Uh-huh.
Then now you have to tell me the third place to go.
Yeah, go diagonal to 4.
4 is an entire column. A4,
A4.
B4, A4. Okay.
And then back to A1.
Nice.
And
Now,
then,
Maeve, do you see this dot in the middle here?
oh yeah.
Are you ever going to be able to get that dot?
Nope.
No. And remember, we had that problem on the last one, but that was a really, really cool attempt. Does anybody have the other solution? I see, Jesse, I don't know if you have your hand up, buddy. So hard to see. No. And I see
I do.
Hayden. Hayden, go for it, kid.
So you go from A1 to A5.
From A1 to A5.
And then you go to E1.
Okay, got it.
And then you go back up to A1.
Yeah, you can't go back to A1 because you're already touching A1. So you've got to be on a different vertex.
Yeah. So then the triangle in the middle of that triangle.
Okay. You would say C2 to C to D2 to D3. Always describe it.
And then you go from A2 to A5 to D5.
Right. But unfortunately, that leaves us with one empty dot. Remember the one that Maeve tried? That was very good and very courageous. Sarah, go for it.
I'm not sure if the triangle will work, but I think I might have one.
All right, I cannot wait.
Okay, so it goes E1 to A5. And it's E1 to E5 to A5.
E1, E5 to A5.
And then you connect the E in here. And then there's a small triangle from D3 to D4 and C4. Yeah.
But
and
you're gonna have the same problem with this guy.
Yeah, but I did different triangles. I did a triangle from D1 and C1 and C2.
D1 to C1.
Yeah.
And C2.
C2, and then connect those. And then I was wondering if I could do one from, well, this one I think I can do, but I'm not quite sure. From B1 to B3, and then you go diagonal, but the point is up in so you go to B3 first.
Okay, also B3.
Mm-hmm. So you go B1, B3, and then, but you start on B1, and then you go to B3.
I just did that.
But that's A3.
Then you go to, I
think what she's trying to say is you delete the A3.
So B1
yes, you go
to
B1 to B3.
Mr. Kramer.
Got it.
And then go up in a diagonal line to C2, but I don't know if you can go up.
Well, you can't go back to C2. C2 is already occupied.
A2, can you go there and then keep going so so it's there, yeah. And then do another triangle from A3 and 4 and then go one unit above.
Yeah, but first of all, this one is violating the rule because it doesn't touch 3 points, and you have 5 triangles. So we need to have a minimum number of triangles. Okay, now, did anybody solve this with 3 triangles going outside. Anybody want to share? So what we're going to do is everybody look at Mr. Kramer's diagram, and I'm going to give it a shot right now. I don't know if it's going to work on the first one. Let's try it. Are you ready? So the first thing I'm going to do is I am going to do, I'm going to go way above, and I think I need to make it a little smaller. And maybe I didn't capture it just right yet. Maybe I didn't capture it just right. No, that's not going to work. So let me now try to make that smaller. And I'm going to see, no, that's the same one we got already. Maybe we can try one more up here. I'm going to go way, way up here. All right, you guys ready? I'm going way, way up. I don't know if this is going to work, but I'm going to try to go all the way and then make it even bigger. Now watch this, guys. Now I'm going to try to go there. No, that was too big.
Oh, Mr.
I think we got it, guys. I think
Mr.
we
Kramer?
got it. Hold on, Baram. Is that 3 triangles?
Yes.
We did it. So sometimes you really have to go way outside the box. I ended up going 4 units above A1. Don't be afraid to go far above. Now, Baram, you had a question.
It isn't a question, but there's something I want to tell to you. There's something I need to tell you. I want to tell you after the class, because earlier today when I was doing my math homework, I realized a subtraction pattern.
Awesome, awesome. Can you send it to me in a chat, please? Because I have a class right after this one. So if you send it to me in a chat or send it to me in an email, I can then look at it. So guys, the 5x5 has 3 triangles and they both went outside. Now, who has a conjecture for how many triangles we're gonna have for the 6x6? Who thinks they know if we can do it in 3? Tess, what do you think?
I think we can do it in 3.
And does anybody else think we need more than 3? And I'm gonna tell you right now, Sarah, do you have a conjecture?
I think the pattern of what it looks like right now is it might be like 1, 2, 3, 3, 4, 5, 6, 6, 7, 8, 9, 9 because of the way it already is.
Whoa,
Or it could be
interesting, interesting. Everybody really quickly, go to page 5. Go to page 5 and try to find at least 2 solutions. Go for it. And by the way, little hint, one is an inside solution, one is an outside solution.
Oh,
One
Mr. Kramer?
isn't. Yes, sir.
I sent it to you in a chat, the thing that I noticed today.
Okay,
Or
great.
can I just say it out loud? Because it's really
No,
short.
I want you to work on what I just did for the rest of the class, and I'll look at it right now.
What page are we on? Found one.
We are on
Page 5.
We are on page 5. Thank you.
I found one with 4. Yeah, that's why I hold it. Mr. Kramer,
Yes.
I figured the two patterns.
Awesome. I can't wait to see them. Jack, what about you, buddy?
I found one that's 4.
You found a 4? Cool. Try to find the second one now. Try to find the second one. And Bayram, I'm gonna try your conjecture to see if it works.
I tested it 3 times, so it probably is right.
Well, 3 times doesn't make a
Well, not including negatives. I'm not including negatives.
and I won't include negatives either. Mark,
Oh,
Can
sorry.
I show you what it is?
what do you mean? Can you show me what it is?
Like what the pattern is?
How many did you find?
2.
Cool. Hold on a
Sorry.
second. Now,
Mr.
Bayram,
Kramer,
just so you know,
I left
Bayram,
out a key
I
piece
just-
of information. I
okay.
left out a key piece of information. It only works with 3-digit palindromes.
Ah. Okay, because I tried a 4-digit and a 3-digit, and it did
Yeah.
not work.
It looks
Um,
so if you subtract a 3-digit palindrome from a 3-digit palindrome, it'll always equal a palindrome.
Okay, everybody keep working, because I want everybody to have 2 solutions here. I think I like your conjecture, Bayram.
Mr. Kramer,
I'd love to see a, who's that, Mr. Kramer? Who just said that?
Kelsey.
Kelsey,
I think I found
cool.
all of them.
I found 2 of them.
All right, who's gonna give me the outside the box solution?
Can I do that one?
Can I do that
Um,
one?
Well, Jack, are you raising your hand? I don't know if your hand's raised. And also,
I want to do the inside one.
okay, who's got the outside one?
Can I?
Sunyi, do not wave your hand, please. I will not call on somebody who waves. And Sunyi, if you want to be seen, move your computer down like I asked Alexander to do, and that way I don't just see the top of your head. Okay? I'm gonna go with Jonah here. And Jonah, I want it really fast, buddy.
Mr. Kramer, I wasn't raising my hand. I'm still figuring it out.
Oh, okay. I thought you were. I
I
thought you
have
were.
it.
And who's the I? So hard to. Who's that?
Hayden.
Hayden's got it. Good. And Hayden, you've given me a bunch, which is awesome. And I'm gonna go with, I think, Gabby.
I don't yet have the outside the box, but I have the inside.
Okay, give me the inside, kiddo.
The inside is point A1 to F1 to F6.
Keep going.
And then you do point C2 to E2 to E4.
Keep going.
And then you do point A2 to A6 to E6. And then you do point B4 to point B5 to point C5.
Wow. That was, oh, by the way, somebody is clicking on their computer really loudly, and it's kind of loud. So if you could not do that, that'd be great. And
I got the same exact one, and I got another one.
did you get another one, Jesse, on the going outside? An outside solution? Okay, Jesse, go. Go, Jesse.
So it's outside. I don't know how many units it is. So can you see this?
So why don't you guess? How many units, buddy? You got to give me a number of units.
Probably the from it's basically one above a unit and a half above A1.
It can only be single units.
Okay.
Is it like
One-
this? Is it like
one
this,
unit
Jesse?
above. Yeah, like that.
Okay, so that is actually 3 units above.
No. A little bit smaller than that.
Okay, I can go 2
Yeah.
units above.
Just exactly on the one. Exactly on the one.
Okay,
It reaches,
that would just be 1 unit above.
and it only goes up to F6.
Yeah, but buddy, you're not, oh, to here? No. So what's gonna happen for you, Jesse, is you're not gonna be able to get point B5. Point
No.
B5 is not gonna work, neither is point
I got it.
D3.
Can you see mine?
Yeah, it's hard to see it, Jesse.
Okay, I'll try a little darker.
And
Plus
guys,
1.
why don't we try going 2 above A1? And then we can go,
Do you see the second one? It's the second
well,
one.
I'm gonna try what I think you might have done, Jesse. Is this what you did, Jesse?
No. Yeah.
Did anybody get that solution? Good. Now, we have 4 minutes left. I want you guys, remember, this was 4 triangles. Let's go back to our graph, and I want you guys to fill in the graph. 4 triangles, both inside and out. I'm gonna give you the solutions that I came up with this week, and I want you to try them. For the 7x7, 5 triangles. For the 8x8, 5. For the 9x9, 6. And for the 10x10, 7. And I would like you guys to try to find all of these. Now, one of the things that I'm really excited about is exploring the area of the regions. And that's something that we may do next week. And I want to show you what it's going to look like. We're actually going to find the area, not of the triangles, but of the borders of the triangles. We're going to find the area of these borders, and it's going to be really, really fun to do. And you guys are going to learn a lot about different mathematics. But I will tell you this, the bigger your array, the more interesting are your borders. So let's look at this one here. Do you see those 2 borders right there? Are those 2 borders the same area, or are they different?
Different.
Yep. The one on the bottom left is going to be bigger than the one on the top right. And we're going to find out exactly the number of units of the area. And it's going to be a lot of fun. But trust me, we are going to be working with things like the 10x10 array. Now, wait, where is the 10x10 array? Maybe I didn't give it to you. Oh, I wanted to show you something else. I also gave you guys a page that has just dots. If you go to page 12, that means that you could make any square array that you want. Let's say you want to do, I don't know, like a 20x20. You could try to do that. You could do any size that you want. So remember, the only one you can't do
I was trying
is
to
the
do
1x1.
12 by. I guess
12x12?
16.
Cool. What about you, Gabby? What were you going to say?
Can you do something like a 7x6? Or do they have to be the same number?
So, Gabby, you're always thinking outside the box, and I love that. I want you, Gabby, to do that exactly. Try to see if you could come up with an algorithm for oblong rectangles like 7 by 6 or 5 by 4. Maybe there's a really cool algorithm we could come up with. Penny, last question. Penny, last question, honey. Go ahead.
Sorry, it was the same as Gabby's.
Oh, cool. All right, guys. I will see you in a week's time with really cool border area. I hope everybody, by the way, say goodbye to your buddies. Say goodbye to your friends. And say,
Bye.
12 by 12.
10.
yeah, William, send me your 12. Send me your 12.
Okay.
Bye, guys. Oh, Jack, nice glasses, buddy. Bye, Tess. Bye, William. Bye, Hayden.
Bye.